there would be times you would encounter something like this: sine x plus cos x minus 2 root 2 sine x cos x equal to 0. That means, the expression would involve sine x plus cos x as one entity and would involve some sine x cos x as another entity. It's going to be a function of sine x plus cos x and sine x cos x, for example. What do you do with something like this? What we can do is realize that sine x cos x is actually half of sine x plus cos x whole squared minus 1. Do you see this? Why? See, sine x plus cos x whole squared is like a 1 plus 2 sine x cos x minus 1. So that makes it 2 sine x cos x by 2. So that makes it sine x cos x. Sine x cos x can be represented in terms of sine x plus cos x in this manner. Half of sine x plus cos x whole squared minus 1, right? So the whole thing then could be expressed as a function of sine x plus cos x alone. So in this case, I have like a sine x plus cos x minus 2 root 2. The sine x cos x can be written as half of sine x plus cos x whole squared minus 1 equal to 0, right? So now we have sine x plus cos x as an entity which I can take as sine x plus cos x, I can take as some z, So this equation is like a, so this goes away. This equation is like a z minus root 2 z squared minus 1 equal to 0. Z minus root 2 z squared minus 1, where sine x plus cos x is chosen as z. So this is like a root 2 z squared minus z plus root 2 equal to 0. Now I can solve for z, Sridharacharya. Z is going to be minus 1 plus minus root 1. So I have root 2 z squared and then minus z plus, so this is going to be minus root 2 minus root 2, see, plus root 2 going on this side is going to be minus root 2. So I have minus b plus minus root b squared minus by 2 root 2. This is what I'm going to get by 2a. So this is 1 plus minus 3 by 2 root 2. So if I take the plus sign, 1 plus 3, 4 by 2 root 2, that means 2 by 2 root 2, which is 1 by root 2 is what? 4 by, so 2 by, so that's root 2 is one of the values that I get out of this. The other value, if I take 1 minus 3, so minus 2, so that will give me minus 1 by root 2, right? So these are the two values of z that I get, 1 root 2 and minus 1 by root 2. So let me start with one at a time. So the first one, which is like sine x plus cos x, which is my z. My z was chosen as sine x plus cos x. So sine x plus cos x equal to root 2. Let me find the solution to this equation. I divide by root a square plus b square. That means I divide by 1 by root 2 sine x plus 1 by root 2 cos x equal to 1. That's what I get, right? And this 1 by root 2, I could have written as, say, cos pi by 4. And this 1 by root 2, I could have written as sin pi by 4. So I have like a sin a cos b plus sin b cos a, which is sin a plus b. So sin of x plus pi by 4 equal to 1, equal to sin 90. Equal to sin 90 very clearly. If sin theta is 1, theta must be an even multiple of pi plus pi by 2. If sin theta is sin 90, or if sin theta is 1, in fact, in general, if I say sin theta is 1, when is sin theta equal to 1? So when I say sin theta is 1, then the rotating line must coincide with the positive direction of the y-axis. Now this line is 2n pi. So every time I add pi by 2 to 2n pi, the rotating line will coincide with the positive direction of the y-axis. And every time it coincides with the positive direction of the y-axis, sin theta would be 1. So sin theta equal to 1 would be like theta equal to 2n pi plus pi by 2. So that gives me one value of x. That gives me one possibility for x. 2n pi plus pi by 2. I get like a x equal to 2n pi plus pi by 4 is what I get. Pi by 2 minus pi by 4, that makes it pi by 4. That's one solution. That is when I take z equal to root 2. But sin x plus cos x equal to minus 1 by root 2 will give me another solution. Right? So this would be one solution set to the mother equation. And then I could have had, say, sin x plus cos x equal to minus 1 by root 2. Right? Again, I divide by root 2 both sides. So if I divide by root 2, root sin x plus cos x equal to minus half, right? And again, this could have been written as cos A cos B plus sin A sin B. I could have, for example, written this as cos of pi by 4. I could have written this as sine of pi by 4. And then I end up getting cos A cos B plus sin A sin B, which is cos A minus B, cos of x minus pi by 4 equal to minus half. Minus half is what? Cos 120 degrees, which is like cos 2 pi by 3. Cos theta equal to cos alpha will give me what? Theta equal to 2n pi plus minus alpha. So the solution to this is going to be x minus pi by 4 equal to 2n pi plus minus alpha 2 pi by 3. I could transpose this pi by 4 on the other side and I would get this general solution. So x could be either 2n pi plus pi by 4 or x could be pi by 4 plus 2n pi plus minus 2 pi by 3. In fact, there are times you would encounter sin x minus cos x and sin x cos x. So sin x cos x could also have been written in terms of sin x minus cos x. How? Very simple. See, 1 minus sin x minus cos x whole squared by 2 will give me sin x cos x. So there are times when you encounter sin x cos x in an expression and sin x minus cos x. Then that sin x cos x that features in that expression could have been written as 1 minus sin x minus cos x whole squared by 2, and the whole thing could have been written as a function of sin x minus cos x, right? So this is another very common variant in our journey into trigonometric equations. Thank you so much. Bye.